which is kind of its own thing, but they're not the same profile, but they still match up on that pitch diameter. Okay, as long as they hit there and we transfer that power. Are they the same size? This one's got a pretty big diameter, is that one? No, not even close. But they'll still match up on the pitch diameter. So this has got a pitch diameter, this has got a pitch diameter, that's where they're going to meet. That's where they're going to match. So I think you're confusing the issue. The teeth are somewhat related. The size of them, because the diameter of this is much different than the diameter of this. Doesn't have to be the same. What has to be the same is the kind of interaction that goes on, but they're two different devices.
So the shape of the tooth doesn't have to be the same?
No, the shape of the tooth doesn't have to be, no.
So are you able to know just by looking at like diagrams or the numbers, that are the catalog numbers, whether a certain gear will mate with a different gear? Or is it just a trial and error?
Yes, manufacturers of these, they want to sell their product, and so they are going to put on a catalog page all gears that will interact with each other, or a section of a catalog. Kind of like when we, remember looking up floor joists and beams and stuff? Did we go out and load up a beam and break it? Did we do any math on it to figure out how strong it was? No, the manufacturer wants to sell them. They gave us a chart. Said, oh, you're going to put this much weight on it? Use this guy. Yeah, they do the same thing, Cheryl. You bet.
So like this, this is that stuff.
Yeah.
This is where I want- Okay.
Yeah.
That was a good question, because I was going to ask if that's a coincidence that we had both of what we needed on one page, so thanks for that question.
Okay, the ones I've got circled are the ones we need. I figure everything on here, definition-wise, is fair game for like a picking scenario. I figure all the ones I've got circled on there are fair game for picking, mathematics, whatever. So you might want to make a note of those, just highlight them or something in your text on the diagram, and make sure you really kind of concentrate on those. Now, certainly I think, you know, we've got, yeah. Because that's all the ones we use right there. Let me add one more. I can't do a pressure angle without a radial line.
You said the circular pitch was the same as
I don't have circular pitch done, but circular pitch is the distance from a point on one tooth to the same point on the next tooth, but it's measured along the arc. Where pitch is a linear measurement, right? It goes more like a chord. It's like the longest review in history. But it's good stuff. There's a lot of technical terms here. It's good to go over it again. Should we walk away from this? Are we good? Are there any other questions? Okay, I think that's probably a pretty good review for the academic or background knowledge of gears. Again, like I told you, we're not going to do any drawing on this one. You've already got the gears. Going once, going twice.
So,
Oh, next chapter. $25, permanent fasteners, of which our most popular one is welding. Now certainly we just kind of went over this yesterday, so it is fairly new. So you have a little bit to store in the old memory cells before test time tomorrow. First, we went over our different scenarios or configurations of material that we're trying to fasten. We went over the reference line and how it works. Any questions on this?
I have a question.
Okay,
So if you're looking at your, page 1203, your little symbol chart that you gave us, there is a, no, so to do a field weld, there's a leader and a field, this one right there,
go ahead and grab a pen and just circle it there.
that one. Why can't, so you're doing two, what, you can't put that on one? And so that means. you know, when you do-
I'm sorry.
You know when you do a line, you do a leader going this one, that one, so that's, so you're not going top and bottom of it, that's, I'm confused, why would you use that one?
Supplementary symbols is what you're looking at here. Okay, so they're just symbols that go on here outside of the base information, which is size, type. So this would be outside of that. So we've got a bunch of these, and they can just occur. These two occur on the shoulder. These are just kind of laid on the line.
Oh, so it's just showing that those are, okay.
They're just little different symbols. They're not giving you the complete story here. They're just saying, if you see this circle that's around that shoulder, weld the whole thing. If I wanted you to do it on the project site, I'm gonna do a field weld, right?
Okay, so like in, so below then, so that's on the back in that space, you're putting something in between the two. Okay.
Yep.
So those would all be in addition to using all the ones up there.
Now, I want to kind of go back to it, so certainly this is an important page, and I plan on getting to this, but let's look back on the academic portion of it. Real quick, and make sure we get thorough coverage on that.
Okay.
What are our two welding processes? Anybody know the answer to that?
Liquid or solid?
Yeah, liquid and solid. What's really the difference between the two?
The heat transfer, I guess.
Yeah, that's really kind of it, it's heat transfer. If we're doing some type of solid permanent fastener, we're using pressure, right? To put those devices together. Like if I'm doing an interference fit, which is considered really a weld, or it's not considered a weld, but it's considered a permanent fastening method. And that I take a shaft that is always bigger than the hole I'm trying to put it in through, and so I shove it through there, and it removes material from both devices. It's on there, right? Baby's not moving. If you want it off, get a torch, you're gonna have to cut it. That's a solid state. We focused on liquid state, which is providing energy or heat to, in essence, melt material. And this is really kind of shown on page 1189 with this little chart. So in essence, what we want to do here is we want to melt material, let it kind of get homogeneous or joined together, then cool as a solid unit. What's weldment mean? Weldment. It's the material you're adding. Should it be weaker, the same strength, or stronger than the material you are trying to join? Yeah, figure it's stronger. You could go same material, but you're kind of degrading the metal a little bit. So if you put the same material on it, then it's probably going to be a little weaker. But anytime you heat things, you're generally degrading it in some form or fashion. So generally we add stronger stuff. So when it cools down, it's going to be degraded also, but it should be stronger than the base material. That's in essence what we want. Nobody wants that fastening joint to fail. We talked about several different types, whether you're using resistance, like on those spots, right, where you're shooting infrared beams or electrical beams or something to some spot that's inside of something. We can do direct, such as arc welding. And then you also have the gas types, which I think several of you said you had soldered and done things like that. But you do that kind of with a heating iron, right? As opposed to a gas. You don't need that much heat for those types of metals if you're soldering. All right, I think the rest of it is really kind of examples of different types of welds. So let's go to Lisa's stuff. Are there any questions on kind of the academics of welding, at least as far as directed by the author? I told you to know pages 1203, 1204. Folks, you will have welding symbols on this drawing. You will be asked information on those welding symbols. You're even going to draw your own welding symbol based on a setup, so know it both ways. Maybe a better way to state this, just so you know where I'm coming from. These two sheets, by the way, 1203, 1204, they'll give you every answer you need if you know how to read them. But expect on the test, expect something like this provided on it, and you get asked a bunch of questions on it. And it may have some other things on it, like that. In fact, let me add something to it. So you know how to do this. Now, how would I solve this? Because I don't really expect you with one day and no welding and doing one welding drawing to have all this stuff memorized. I don't expect that. And in fact, I've never done a ton of welding. I do welding, I mean, as far as drawings go, but I got to review because it doesn't do it. I don't do it very often. Like Missy, I mentioned yesterday, I was doing a development. I had to reteach myself. Okay? Well, welding's kind of that way for me too, because I'm mostly the civil type of guy. I got to reteach myself. But you'll find you do that on the workplace all the time as a drafter. Okay? Haven't done something for 6 months. Your answer to the boss is, I don't know how to do it. Your answer is, sure, I'll go do it, but I can't remember. It's going to take me a little bit longer because I got to look and figure it back out. So how would you do this? How would you know it?
Fill it, you look on the chart here.
Okay. So look at what's the size of the weld? What's the size of the weld?
20.
20. Which sheet are you on to get that information, Lisa?
1203.
1203. So you see where, and you're looking,
Top is fillet, that's
Yeah.
cylinder.
you're looking at that diagram of the reference line, and it says the size sits to the left of the symbol, right? Okay. Size is also considered kind of the strength, but they call it different for different welds. What type of weld is it?
Fillet.
It's a fillet weld. Where's the symbol at? Is it 1203 or 1204?
1203.
It's on 1204, right? Isn't that where your symbol's at?
Oh, that's just right there. I don't know, I got it from the same page.
It's probably on both pages, because it's a pretty popular one, but
Yeah.
there's, on your cheat sheets,
Yeah, it's.
they have both. Yeah, so they got both symbols on the very top parts of both of them. I lost my little thing, I'll turn pages. There, go back to the encircle. What's the pitch?
120,
What's the length?
60.
Why are the symbols offset?
Those are first sides.
Yeah, we're doing both sides of the joint as shown. So, we're coming here. So I see this joint and this joint in this view. So I'm welding this side and that side. Why aren't the symbols lined up? Like on this one,
Because your welds will be offset.
staggering the sides.
Mhm.
If they're like this, they're matching up. Is that on your cheat sheets?
Mhm.
You see it, Missy?
I do, but what's the difference then between double and chain?
I'm
Those look the same.
sorry, where you at?
They have double,
Oh, one chain.
it's the first box,
You're on 12, which page?
1204.
1204.
Okay.
Double foot.
The first one's a double fillet welding,
Yeah, so, because it's on both sides of the line, right?
and it's the same as the one next to it, the chain intermittent.
They're different size welds. Now, means that their double welds are identical, except that we have different sizes, right? But the length of pitch is the same, the weld is the same, the location is the same, the only thing that's different is the size. One's 7/16 on one side, one's 5/16 on the other.
Missy, it also, the second set of numbers says 2/6 on the intermittent.
It says the length is.
And that, just the fact that it says -6 kind of is giving you a hint that it's going to be staggered. Isn't that right?
No,
No?
no.
Because it's not staggered, it's
Um,
the same.
You're looking at this top line here, right? I think what all they're saying on this is, this is a double fillet, we're on both sides, right? So we're doing both welds. Okay. They're gonna match up, this has just got length. Now this one's got pitch added to it because it's an intermittent. They're different size welds, but it's an intermittent by that. This one is just the length of one weld. This has only got one weld on it. Length of 4. It's got one weld, length of 6. This one's gonna be repeating. It's got a longer thing, intermediate. This one's intermittent, but it's staggered on either side.
Oh, so the staggered is that.
When the symbols are offset. A good exercise to learn how to read this sheet and everything these are trying to tell you is go through the chapter and look at the figures and don't read anything around it, just look at the weld number. And then go to here and see if you can figure it out, and then go read what it tells you that it is.
So we're gonna have these,
I will give you those. You will have those 2 sheets
okay.
on the test. That's your cheat sheet for the year.
Okay.
Yay.
Okay, so expect something like that. Fumbly fingers.
This is the time you want to sit next to Sean.
Too bad what I'm on China. Expect also a setup that maybe looks something like this. where I just give you some dimensions on a figure, and I say, please write the well note for this. So if you're writing the well note for this, and we knew that this was 1/4 inch. Does anybody want to come up on the board and write the well note for that? Ooh, I'll do it. I'll give you a hint, it'll be a reference line.
Then it'd be a, what, the,
And then what am I going to put on? Let's start with the symbol.
Fill it well.
yeah.
Okay. I'm going to use a fillet well.
Yep.
Do I got to put it on both sides?
Yes.
Yes.
Yes, I do.
Size is 1/4 inch
Where does that go, Sean?
to the left of the symbol.
Do I have anything else?
Mm,
No, nothing. Nothing here, nothing here. Don't need the tail, because I'm not telling them how to weld it. But that's it. It's a continuous weld throughout the whole joint, so I don't need size. Kind of like a hole that passes completely through an object, right? We don't give them the depth. So it'd be a good exercise to look at your different welds and be able to do that. You can do that right off of those cheat sheets also. I will tell you, I mentioned 2 welds that are as a general purpose fastener that are much more popular than the others. Fillet weld, very popular one, works in most of those configurations. What was the other one?
Butt weld.
Yeah, which is the classification of them though.
Seam?
What do we use in a butt situation or an edge situation, and what type of weld is really kind of preferred in those?
Oh, liquid.
There's a
Oh, groove weld.
whole bunch of them.
The bevel?
Yeah, the bevel, and Missy really kind of hit the general classification, which is the grooves. But there's a bunch of different joint preparation types, of which probably the V and the bevel are the 2 popular ones, because they're fairly easy to do. All right, I think if you know that, you're going to be pretty good on the welding section. Any questions for me? That's the end of my review.
Yeah.
Yeah.
So if you ask a question of the 2 most popular welds, you have fillet, bevel, and V-groove, then what are we gonna say?
I won't ask that. I won't ask that question because
Okay.
I mention those because you see those over and over and over again because they work in most of those situations, right? And so you're going to use probably, I don't know, if you're doing 10 welds, I pretty much guarantee you probably 7 or 8 of them are going to be fillets and grooves. Now, I don't want to get the hint that that's all you use. There's a lot of other types. It depends on the material. It depends on the type of connection you want to make, all that. They all have their place.
going back to this, the well note that you did, you put the 1/4 inch on the top and, did I just miss writing something?
Top and the bottom,
Oh, okay,
it's for both
I did it in
sides.
both.
okay.
So I'm just gonna jump to 1204, because I know if we just looked at these figures. Keep in mind, there are 2 types of wells that you have the capability of giving them information about with 1 reference line. The information on the bottom goes to what? The side the arrow is pointing to. Most joints have probably, what, 4 sides? Think of pieces going together, right? Height, width, depth, you get those double around. What's the top one for? The side away from the arrow. Is that what you were asking, Cheryl? Yeah, that's certainly important.
So that's the bottom information goes
And so you really can.
Let's look at a better picture of this. I think on the fillet section, they had some good pictures of this. Page 1194. Actually, kind of like the one I dealt with earlier better, because this is better. So the well note goes where